The slope or rate of change between 2 points is defined as the symbol we use is m equals the slope equals the rise over run, the vertical change over the horizontal change, the change in y divided by the change in x, or with a formula, m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Those subscripts, 1 and 2, are just telling you that you have the first xy point and the second xy point. So x1, y1 is the first point, and x2, y2 is the other point. So given the following displays, find the slope between the points. Here we have a point at 2, 3, and another point at 6, 4. If we just use the concept of rise over run, or the vertical over the horizontal change, to get from point B to point A, we can go up 1, or rise 1, and to the right, 1, 2, 3, 4. So right 4. So if we count up 1, right 4, that will keep us on that line. So that's just looking at the rise over the run, up 1, right 4. The way you write that mathematically is the fraction, m equals 1/4. Using the formula, y2 minus y1 over x2 minus x1, if we looked at point A as the first point, and point B as the second point, this is like x1, y1, x2, comma, y2. And it doesn't matter which way you define those, and I'll go over that in a minute. So if you just use the formula, y2 minus y1 is essentially just the change in the y values. So if we go 3 minus 4 divided by 2 minus 6, that'll give us -1 divided by -4, which reduces to a positive 1/4. So we already mentioned that if you start at point B, if you go up 1 to the right 4, you end up on this point A. Well, the -1 over -4, what that's saying is if we went from point A to point B, so backwards, so basically change both directions. If we go down 1, left 4, so -1 over -4, will take us to point B. So that's mathematically how that works. If we would have defined the points backwards, so instead of subtracting 3 minus 4, if we did 4 minus 3, we have to switch the other order also to keep the points consistent. So if we switch the 3 and the 4, we have to switch the 6 and the 2. So 6 minus 2, and notice what that does. That gives us a positive 1/4. Okay, so either answer is the same. It just depends on how you define x1, y1, and x2, y2. So moving along to the next pair of points, 1, 6, and 3, 2. To get from one point to the other, if I start at 1, 6, if I go down 4 and to the right 2, so down 4, right 2, that will be a slope of -4 divided by positive 2, which reduces to just -2. If I use the slope formula, so if I just start with the y value of 6 here, so I'll start with this point, 6 subtract 2. I started with the 6 for the y value, so I'm going to start with the 1 here. 1 minus 3. And if I simplify that, that's 4 divided by -2, which is -2. Okay, so the slope is -2. Notice if I were to reverse those, 2 minus 6 will be negative 4, and 3 minus 1 will be positive 2. That would still give me negative 2 though when you reduce them, because that'd be negative 4 over positive 2. Okay, and then notice if from this point I counted up 4 and then to the left 2, that would take me to the 0.16. Same as going down 4 and right 2. Okay, and then the next point, or pair of points, 3, 2, and 7, 8. So to get from 3, 2 to 7, 8, I have to go up 6 and to the right 4. So up 6, right 4 gives me a slope of 6 divided by 4. Okay, positive 6 because we went up 6, right 4 because, well, positive 4 because we went right 4. If I use the slope formula, and I should say that reduces to 3 over 2, or 3 halves. If I use the slope formula, I could start at, let me start at 7, 8. And to get to 3, 2, we have to go 8 minus 2. And 7 subtract 3. So that'll give me 6 over 4, which again reduces to 3 over 2. Okay, and then on the second page, you can practice these two. You want to plot the points first, and then find the slope between them. So I'll let you pause the video for a minute, and then I'll put the answer up. So pause the video. So here's the answer for that. With negative 4, 6, that's a point right here. And then 2, 3 is this point. So it looks like we go down 3 and to the right 6. That shows up when you do the slope formula. Negative 3 means you go down 3, and then positive 6 means you go right 6. So that reduces to a slope of negative 1/2. So that's saying that if we start at negative 4, 6, if we went down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, we end up, we had to do that 3 times, and we end up at the 0.23. And then the last pair of points, 8, negative 1, so this point here, and 2, negative 3. If we do y2 minus y1, so negative 3 subtract negative 1. And this is where you have to be careful with your signs. We're always subtracting y values in the numerator and x values in the denominator, so you have to be careful of the signs. So negative 3 subtract negative 1. And I will say that it does help some people to write the points kind of above each other, like this. And then you can say y minus y, x minus x. That helps some people. So when you reduce that, you end up with negative 2 over negative 6, which reduces to positive 1/3. So that means if you count up 1 to the right 3, so from the starting point here, up 1 to the right 3, up 1 to the right 3, we stay on that line. The effect that reducing the fraction has, the reduction just tells you how many times you're going to count the simplified slope. So again, what that means is a slope of 1/3 that reduced from negative 2 over negative 6. So you basically divide it by 2. So that means that we had to go up 1 to the right 3 twice. Okay, so one time to get here, and then the second time to get here.